In its simplest definition, a rocket is an open-ended tube filled with fuel. When the combustible and oxidizing materials combine and ignite, the generated power exits from the open end, propelling the rocket in the opposite direction. Rockets can be categorized into three main groups based on the types of combustible and oxidizing materials used during ignition: liquid-fueled, solid-fueled, and hybrid rocket engines. Among these, solid-fueled rocket motors are often preferred by rocket designers. Welcome to the Spaceship Earth. In this video, we will discuss what solid-fueled rocket motors are, how they are made, and the characteristics they possess. The history of solid-fueled rockets dates back to 13th century China, where gunpowder and the earliest rockets were invented. While gunpowder was used as fuel in the early days, much more effective chemicals are used today. In modern rockets, aluminum powder is commonly used as fuel, while ammonium perchlorate is used as the oxidizer. The fuel for the rocket is poured in a specific geometric shape into the outer casing, which serves as both the protective layer and the mold for the poured fuel. The shape of the mold varies according to the desired burning rate and power. In most rockets, the center of the fuel is left empty for combustion. In such rockets, the thrust power increases as the burning surface area increases after ignition. Another molding method is called the star method. In this type of molding, a star shape is prepared to create a wide burning surface. This design in the rocket generates significant thrust power during ignition. For example, during the liftoff of space shuttles, 2/3 of the thrust was provided by solid-fueled motors molded in a star shape. Solid-fueled rockets have their own advantages and disadvantages. Advantages of solid-fueled rockets include: solid-fueled rockets produce more thrust power compared to a liquid-fueled rocket of the same volume. Their structures are simpler than liquid-fueled rockets, which involve multiple engines, plumbing, and valves. The manufacturing process is simpler. Transportation and storage are also more straightforward than for liquid-fueled engines. Due to their ease of manufacturing and fast production, they are cost-effective. Their powerful and cost-effective nature results in a high thrust-to-cost ratio, which is why many rocket producers prefer to use solid-fueled engines as their main or booster engine in rockets. Disadvantages of solid-fueled rockets include: solid-fueled engines cannot be shut down once ignited. They burn continuously, similar to a matchstick. Once ignited, they will not stop burning until all the fuel is consumed. Therefore, multiple ignitions cannot be performed, and they cannot be shut down for safety reasons in case of emergencies. Additionally, the thrust power of solid-fueled rocket engines cannot be easily reduced or increased as desired. The burning rate calculated during the manufacturing process determines their burn rate and duration. Although solid-fueled rockets are powerful, but not efficient, the fuel-to-energy conversion rates are lower than the liquid-fueled motors. Thrust control is limited in solid-fueled motors. Liquid-fueled rockets can control their thrust by changing the direction of their nozzles or engines. While solid-fueled rockets can provide some control by directing the exhaust, they are not as flexible as liquid-fueled rockets in this regard. Solid-fueled engines' burning time is short. The solid boosters used in space rockets generally burn out and separate from the main rocket after 80th to 110th seconds. In contrast, liquid-fueled rockets can operate actively for much longer. For example, in the SLS rocket, developed by Boeing, liquid-fueled RS-25 engines remain active for more than 8 minutes. Despite their disadvantages, solid-fueled rocket engines are extensively used in the space industry, thanks to their numerous positive attributes. Rockets like Boeing SLS, Ariane 5, and Indian GSLV use large and powerful solid-fueled boosters in their first stages. These boosters account for half to 2/3 of the required thrust during launch. Additionally, rockets like Atlas and Vulcan, developed by ULA, can utilize external solid-fueled motors depending on the payload they carry. Finally, there are systems like the Italian-made Vega rocket, which operates entirely solid-fueled at the first stages. Solid-fueled rockets may look crude and simple in structure, but like all aspects of space exploration, they require complex engineering and scientific research. Furthermore, given that they fulfill their intended tasks, it is highly likely that they will continue to be used for many more years to come. Thank you for watching Spaceship Earth. If you found our video helpful, please like and share it. Subscribe to our channel to stay tuned on space and space technology related news.